In this video, I'm going to show you some selected problems from lesson 14 in the Oklahoma Supplement. And this lesson is on the mean of data. And remember that the mean is the average of a set of data. And we can think of that as the leveling out point of a set of data. So if you have a whole bunch of pieces of numbers, we're trying to get all those numbers to level out or equalize. We're going to begin on page 81 in your journal. And we're going to look at problems 9 and 10. For these two problems, the directions are find the missing number from a data set when the mean is given. So on number 9, the mean price of a DVD is $14, and we're given the price of 1, 2, 3, 4, 5 DVDs, but we're missing the sixth number. So knowing that what we can do is, or what we're trying to do is level out all of these prices, and the leveling out point is going to be 14. I'm going to work backwards. I'm going to take the 14, the leveling out point, and I'm going to multiply it by 1, 2, 3, 4, 5, 6 different DVD prices. And that's going to give me a total amount right here. All these numbers combined equal 84. I know that they combined equal 84 because when I level them out, which means I divide by 6, I'll get 14, because 84 divided by 6 is 14. So now I just need to find out how far away are all of these from 84. So I'm going to take all of my prices and add them all up. 8 and 2 is 10. 10 and 7 plus 5 is 22. 2, 3, 4, 5, 6, 7. So it looks like I have a total of 72 so far, and I need 84. So 84 minus 72 will get me my missing value, which is 12. Let's now look at question 10. It says the mean length of a movie is 94 minutes, and we have our data set right here. It looks like there are 1, 2, 3, 4 total numbers in the data set. So I'm going to take my 94 minutes and multiply that by 4. It gives me 376 total minutes that I'm going to want to level out by dividing by 4. But I already know that when I divide this by 4, I get 94. So I just need to find out how far away am I. And that will give me my missing data point. 8 and 7 is 15, and 4 is 19. 9 and 8 is 17, and 1 is 18. And I'm at 289. So to find out how far I am away, I'm going to do some subtraction and do some regrouping here. It looks like I'm 87 minutes away, so my final number right here, my missing piece of data, is 87 minutes. Let's now look on page 82 on question number 11. Question number 11 says Jacinta has taken a total of 5 tests, but she only remembers 4 of her scores. We know what her scores were, 89, 74, 92, and 80. She knows that her mean test score, the average score that she made, was a 79. So we're trying to find the missing score out of those 5 test scores. So just looking at these pieces of data without even beginning, I see ones that are higher than 79, 1, 2 right there. Actually, that one is even higher, just a little bit than 79, and only one that's lower. So knowing that the mean is 79, and the mean is a combination of all of her test scores leveled out, I'm guessing that the missing test score is going to have to be something that's lower than 79, because it looks to me like just these right here, if I were to level all these out, they would be higher than 79. So let's go ahead and figure this out. I'm going to work backwards. 79 times 5 will give me the total points that Jacinta has earned, and that's 395 total points. Of the test scores that she remembers, let's find out how many points she has. 13 and 2, 15, 16 and 1, 17, and 17 and 16 is 33. So we have 395 points that that we know her average will be, and we're going to take away the points that she remembers. And that gives us a final test score of 60 that she didn't remember, which is confirmed by my original estimate that was her lowest test score. Let's now look at question number 12. It says the table shows the number of t-shirts sold each day for 2 weeks. We're going to find the mean and then explain how the mean would change if the two data values of 7 were not included. And I'm actually not going to work out finding the mean on here. To find the mean, we would add up every one of these pieces of data, all these numbers, and we would divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What I want to look at is how the mean would change if the two data values of 7 were not included. These two data values of 7 are our two outlier pieces of data because they're not anything like the other pieces of data. They're much lower. If we were to remove these pieces of data, we would expect that the mean would go up rather significantly, because then the lowest piece of data that we have would be 29 and our highest would remain 45. But our mean would be somewhere between 29 and 45 rather than between 7 and 45. So the mean, when we have all these 7s in here, those 7s are really pulling down all these other numbers because we're having to take away points from them or numbers from them and give them to the 7s. When we remove the 7s, suddenly we don't have to do that, so the mean would greatly increase. And the last problem I'm going to show is question number 14, which says write a data set that has a mean of 14. Obviously, there's lots of ways that you could do this problem. You could take the easy way out and say, here's your data set, and obviously it has a mean of 14. You could do another easy way, like this, because if we took 1 away from 15 and put it over there, we would have 3 14s. The way that I probably would do it is I would probably pick a 14, put it in the middle, then I'd pick something that's a couple higher, then pick something that's a couple lower, pick something that's maybe 1 higher, pick something that's maybe 1 lower, pick something that's maybe 3 higher than 14, and then 3 lower than 14. And here's my data that definitely has an average or a mean of 14. And I know that because every single piece of data, if I added 3 to 14 and I took away 3 from 14, I know that I'm going to have that leveling out point of 14.